All right, hi everyone. I think we're going to start class now. Thank you guys for coming. So unfortunately today is our last class. It's been about 8 weeks and this will be our last lesson, which is the respiratory system. I just wanted to say a huge thank you for, coming in and taking time out of your own day to listen to me and learn new things. Hopefully you've learned something, and it's been a really fun summer for me, with this program and this class. So I hope the same goes to you guys, and just a big thank you. So let's get started with today's class. So what is the respiratory system? So it's basically that system, the system in your body. It's a large network of organs and tissues that basically help you breathe. That's one of the main functions of the respiratory system. And it includes your airways, your lungs, and blood vessels. So it works hand in hand with the circulatory system, as we kind of discussed in last week's lesson. So the muscles that power your lungs are also part of the respiratory system. All of these parts, airways, lungs, blood vessels, muscles, they work together to move oxygen throughout your body and clean out waste gases like carbon dioxide. So, when you inhale, you take in oxygen from, the air around you. And then that kind of goes down, goes through your respiratory system. And then it goes into your bloodstream. And then your circulatory system kind of transports the oxygen to all your cells, making sure that they get the oxygen. And then your blood kind of filters out carbon dioxide that your body produces from waste products back into the lungs, and then you breathe it out. So yeah, really the circulatory system and the respiratory system work hand in hand. It's very important that they work hand in hand. If they don't, then your body wouldn't get the things it needed. And so, like I said before, the main function of your respiratory system is to help you breathe. So, if you can't breathe, if maybe your airways are blocked, any airway, it could be like your trachea, which is in your neck. It could be your nose and mouth, like any part of your respiratory system that is blocked that like can't help you get air. That means you can't breathe. And if you're deprived of oxygen enough, if you're not breathing for a long enough time, if someone drowns or is like choked, then or they're choking on something, they can't get the air to their lungs, and without air going to the lungs, the blood can't circulate it. And then when your brain is kind of deprived of oxygen for a long time, then your body kind of just starts to shut down. And so it's very, very important. And also cleans waste gases, and such as carbon dioxide. There's a lot more from your blood, which is also really important because you don't want that waste to build up in your bloodstream, because that's just really bad for your body and it wouldn't function like it usually would. So these are just kind of like the basic facts about the respiratory system. I feel like are important to know. They're not really like fun facts, but I think they're pretty important. So lungs are one of the largest organs in the body, and they allow you to take in oxygen and breathe out carbon dioxide. The lungs are located in your chest, and they take up a large amount of space. And your thoracic cavity, which is basically your rib cage, your upper body kind of place. Your ribs protect the lungs, so that's why you have so many as we discussed in our skeletal system class, like the reason why you have so many bones in your thoracic cavity and your skull is because it protects like the most important organs. So, your brain is obviously very important. So you have a lot of bones surrounding it, a lot of hard bone, and same with the heart and lungs. You have that your rib cage protecting it, which is very sturdy, and it's kind of hard to kind of penetrate through. And then in the front, you also have your sternum, which protects your heart. So you just got a lot of protection there. And right underneath the lungs is something called the diaphragm. And the diaphragm is kind of like this muscle organ that helps your lungs inhale, breathe in, or exhale, breathe out. So your lungs also work alongside the diaphragm. It's not just your lungs breathing, the diaphragm also helps. If any of you guys are like singers, I'm not very I'm not a very good singer, but I was in choir for a few years, and people say people like music teachers say to sing from your diaphragm, don't sing from your stomach, and um, I don't know that's an expression I heard a lot. And the reason is that your diaphragm helps you breathe better. And if you breathe well, then you can sing better. I don't know. It's kind of like all connected. And then your lungs are actually not the same size. The left lung is actually slightly smaller because it needs room to allow for the heart. So your left lung is actually a little smaller because it needs to fit the heart because the heart actually rests on the left side of your body. It's actually not like right smack dab in the middle like a lot of people think. I thought that was kind of a fun fact, I guess. All right, we're gonna watch this video. It's about the path of airflow. So it's gonna explain how kind of how air kind of ends up in your body from the that your outer surroundings. So how just regular air in your room or outside kind of goes into your body and gives you the oxygen it needs. Let's hope this works. So you can kind of see like that purple, red, blue stuff is actually air. Well, it's supposed to represent the air at least. So it goes in through your nose usually. And it goes down your, trachea. And it goes further down. And yeah, I just thought that was a really pretty video on how you could see it go through the nasal cavity and then straight down. I think that was kind of cool. So this is like it explained a little more because that was just kind of like a basic video. But your pathway of air is basically it first goes in your nasal cavity, which is basically your nose, and there's a long kind of tunnel, if that's what you want to call it, in your nostrils. And then you can also breathe through your mouth, obviously. Either one works as long as you have one. But usually you take in air or oxygen through your nose. I think it's more comfortable. If you might have noticed when you have like a stuffy nose or a cold, it's kind of hard to breathe in just your mouth. It's kind of uncomfortable. It makes your mouth dry. So, and breathing in through your nasal cavity is pretty optimal, I think, to most people. So it goes in. So oxygen-rich air from environment goes into your nasal cavity. And then there's something called the pharynx, which we'll discuss in a minute with a diagram. But it's like kind of like this thing in your kind of throat, your esophagus kind of thing. If you recall, the esophagus is part of your digestive system, but we said that the trachea, which is next, the trachea and the esophagus are kind of right next to each other. So food travels down your esophagus, but sometimes food and water that's supposed to go down the esophagus gets into the trachea, and that's when you start to choke because the trachea is where the air oxygen is supposed to go, not food and water. So your body will kind of reject that from the trachea because it's not supposed to be there. So you'll cough and choke, and which is pretty common for me at least. And then it goes all the way down your trachea. Your trachea is like your windpipe. It's very long. It goes down, and then there's something called the primary bronchi. So the first bronchi here, and then your secondary bronchi, a lot of bronchi, and then tertiary bronchi, bronchioles in alveoli, which is the site of gas exchange. So we'll discuss this later, but gas exchange is basically where you're breathing the oxygen, right? So at the alveoli, it's exchanging the oxygen to your blood, and your blood is giving it the carbon dioxide it doesn't need, and then through the lungs, the carbon dioxide is exhaled. So it's kind of cool. I think it's pretty self-explanatory about airflow. If you take a breath right now, you sniff or breathe in, I guess, and then the air goes down your trachea, goes down your windpipe, and then it goes into your lungs. And there's something called bronchi and all of that. So yeah. So we're going to move on to the anatomy of the respiratory system now. So the respiratory system is divided into two tracts. One is called the upper respiratory tract, and then the second is called the lower respiratory tract. So the upper tract consists of the nose, mouth, pharynx, epiglottis, which is kind of part of the digestive system. It's that flap that keeps food out of the trachea. So it's the flap that kind of prevents food from going down the wrong pipe because there's both the trachea and the esophagus. So epiglottis can be kind of considered part of two systems, I guess. And then there's something called the larynx, and then the trachea. So if you can see here, the upper respiratory tract, that's the nasal cavity. If you can see, that's the nose right there, and it goes down. And then that's your pharynx. It's like this segment right here, and then your larynx is a little bit down. And your larynx is kind of like your voice box, like I'm speaking right now. And if you put your kind of hand or your fingers on your throat, you can feel the vibrations, and that's from your larynx because that's the voice box. You know, when you're talking, the vibrations and stuff and the words kind of come from your larynx. And then your trachea is like this kind of long tube thing. Yeah, and the trachea leads directly to these two this is called bronchi. You can see it kind of splits into two parts. That's the kind of split road, kind of like a split road, you know, it's like a Y. You can go either direction, and it's connected to the lungs directly. That's the primary bronchi. So these two kind of branch things. Yeah, and that's the lower respiratory tract. It's the bronchial tree. I guess it kind of looks like a tree. That's what people call it. And then the lungs. And you can see the primary bronchi branches off into more bronchi. What I like to think of it as like whatever kind of looks like a tree branch, that's basically a bronchi, and it can like split into like secondary and tertiary, like we discussed in the last few slides. Yeah. Oh, and a lot of times, I don't know if you guys watch like Grey's Anatomy. I did for a while, and I noticed that like something they do is, you know, when someone can't breathe, they can't get oxygen in their lungs through their nose or mouth because something's blocked off. They'll like drill. I don't know if drill is the right word, but they like kind of make a hole in the trachea right here. They make kind of a hole and they put a tube actually in the trachea, which looks really scary, but you know, it's direct airflow, you know, usually take it in through the nose or mouth, but then if you have like a hole here, then you can directly take in air because it goes straight to your bronchi and then your lungs. So yeah, there's a lot of ways doctors make sure someone can breathe, because if they're not breathing, then you know their heart kind of stops and like they're just kind of gone after that. So it's very important. Okay, let's move on to the organs or the main parts, I guess, in detail. So the larynx, like I just kind of explained, it's the voice box. Besides being the voice box, it also helps with your breathing, which is why it's part of the respiratory system, a sound production, and it also protects the trachea. So it's kind of like a protective thing also, which is kind of cool. Your trachea is also known as your windpipe. It connects your pharynx, which is right behind your mouth, actually. You can see right there, like that's your mouth, and then the pharynx is kind of right there. And it connects your pharynx and your larynx to your lungs. So it's kind of like that connecting factor between the pharynx and the larynx to the lungs. So it's like kind of like that really long tube. And then there's the right superior lobe, which is, if you recall in our first class, we discussed, you know, anatomical positions in words. So superior means upper. So the right superior lobe is located at the top of the right lung. Your lungs are divided into lobes, which are basically like sections. So there's like superior and like inferior lobes. So the right superior lobe is top of the right one, and then left superior lobe, pretty self-explanatory. It's at the top of the left lung. Then we've got the bronchial tree, which is kind of like that, the diverging tree branches, if I should call them that. Yeah, that's the bronchial tree, and it consists of the bronchi, bronchioles, and alveoli. So what I mean by bronchioles is that these are tiny tubes on the bronchi. So on these like big tree branch things, they're more tiny, they're smaller. And there's actually about 30,000 in each lung. So there's a lot of them. They're kind of like the tiny things you see branching off of the main bronchi. And then alveoli are even smaller than bronchioles. There are really tiny air sacs at the end of each bronchiole. So you can kind of think of it as like a, I don't think food chain is the right word, but like a greater to less than chart. You know, you got the bronchi, which are the biggest, and then the bronchioles, which are part of the bronchi, but they're smaller. Then you have the alveoli, which are part of the bronchioles, but even smaller than that. So it kind of like it's like a greater to less kind of thing. And their alveoli are basically tiny air sacs at the end of each bronchiole, and there's about 600 million. So, you know, they're so tiny that there can be that many. And the alveoli are covered with blood vessels called capillaries. And alveoli, as we discussed, are the things that help with gas exchange. So the exchange of, you know, oxygen and carbon dioxide between your blood and your, you know, lungs, which is, so they play a very important role. And they're covered with blood vessels so they can directly exchange things such as, you know, gas and oxygen and carbon dioxide. So yeah, the little guys play a very important role. And yeah, and here you can see the diaphragm is located on right underneath the lungs. So the bronchi is the extension of the windpipe that brings air to and from the lungs. So it's kind of right there, extension of the trachea or the windpipe, if you want to call it, you can call it either. And so you can see the bronchi, like the trachea is right here, and then you can see it branches off, but it's still like, it looks like it's still part of the trachea. Anything like that is basically the bronchi. And then the smaller things that break off are the bronchioles, and then the smaller things that break off the bronchioles are the alveoli. So you got a lot going on in your lungs. And then we have something called the pleura, which is kind of like a connective tissue. It's a type of tissue. It's not like an actual organ, but it's a tissue that wraps around the lungs and it coats the inner surface of your rib cage. And it has two layers, and located between the two layers is a fluid that allows the lungs to glide past each other while inhaling or exhaling. You know, it kind of creates a lubricant, so like it doesn't exactly like, oh, I'm just cringing thinking about like the lungs just don't like grind past each other, because that could be like really bad. You know, when you have some kind of fluid or something, it's nice because there's no like damage, like it's not dry, and it's like it can like smoothly glide past each other, and that's the purpose of that. Then we have the right middle lobe, which is located in the middle of each lung. So your lungs basically have, well, here's where it gets tricky. You gotta remember that the right middle lobe has three lobes. So it has a superior lobe, a middle lobe, and an inferior lobe. And you can see here that there's no left middle lobe. It's because the left lung doesn't have three lobes. It has only two. It has a superior and an inferior. Basically, the inferior ones are located at the bottom of each lung, and the middle ones are located in the middle of each lung, but only the right lung. And I just put like, it's important to note that the lobes of the lung are named for anatomical positions, so like just like location purposes, and each lobe does not actually have a specific function. They're just kind of split that way. We don't really know why, but yeah, we don't really know why the right lobe has three and the left lobe only has two either, but I just thought that'd be nice to know, you know, because I feel like that's kind of a fact. I mean, I didn't know until I learned it either. So yeah, I just thought that was pretty cool. All right, let's discuss the process of respiration. So there's inhalation and exhalation, and you guys have probably heard of this 1,000 times, you know, when, especially like it, like the process of respiration, you know, inhaling and exhaling, it's used very common. Like, of course, like you breathe every day, everyone breathes every day. But, you know, when like meditative techniques, or like when you want to calm down or feel relaxed, you know, there's a lot of apps that like breathe apps. I know I have one on my Apple Watch, you know, it's like it tells you when to breathe in, and you take in air through your nose, that's inhaling, and then you kind of breathe out, and you're supposed to feel calmer. I personally don't love it. Doesn't really help me, but I know it helps a lot of people. And I think the deep like breathing exercises really help because it brings like more oxygen. It just makes you feel more calm. I'm sure there's a lot of scientific studies behind that. So with inhalation, you take in air through your nose or mouth, obviously, and then your diaphragm actually contracts. And what I mean by contract is that it pulls downward. So when I think of contract, I usually think of like upwards for some reason, but no, you want to think diaphragm contracts. That means it pulls downward. So it goes down as you breathe in, and your thoracic cavity expands when you breathe, and you can actually kind of feel it expand if you breathe in right now. And it produces kind of like a vacuum within the cavity, and then air is drawn into the lungs. And then right after, since you have so much air in your lungs, you gotta, breathe it out, or else it's very uncomfortable. Your diaphragm relaxes and it moves upward. So when it relaxes, it goes back up. And then your thoracic cavity becomes narrow, it pushes the air out. There's no vacuum now, it doesn't expand. And then air is forced out of the lungs. So, that's just kind of the process. So here's like some diagrams. So here you can see the arrows kind of point to airflow. So coming in through the nose and the mouth, and then your chest expands, your diaphragm contracts, it goes down. And then when you exhale, the diaphragm relaxes, it goes back up, and your chest contracts, so it gets smaller. And then here's another one. Diaphragm pulls downward, helping lungs expand with oxygen. Diaphragm return upwards, forcing lungs to expel carbon dioxide. So diaphragm is very important in the process of respiration. I just wanted you guys to kind of see how it all works. Oh yeah, and the pink, kind of like a pink band, I guess. That's supposed to represent the diaphragm, and like this little muscly looking thing, that's also the diaphragm. So I want to talk about next the differences between internal versus external inhalation. So external respiration is when you bring air into and out of the lungs when you exchange gases for air. So you're exchanging carbon dioxide for, good clean air, oxygen. So air is inhaled through the alveoli, which are like this really small things in your lungs, as I discussed before. Oxygen passes in the surrounding capillaries, which are the blood vessels. So when you breathe in, goes through the alveoli because that's in your lungs, and the air eventually reaches your lungs. And then oxygen passes into the blood vessels of the alveoli from your bloodstream, and then carried by erythrocytes, and that's like the fancy word for red blood cells, to the body cells. So oxygen, when it passes, oxygen from the air passes through the alveoli, and which passes to the capillaries. The capillaries have red blood cells in them, obviously, because capillaries are a type of blood vessel in the circulatory system. So the red blood cells transport it all over the body. It gets to your brain, it gets to your legs and your arms. And then waste products, or carbon dioxide, that's the main waste one. It's transported to the air spaces of the lungs to be exhaled. So yeah, and we'll get into more detail about that later. I know it kind of sounds confusing, but internal respiration is the exchange of gases within the cells. So I'd say external, like you think of it as you physically, like you're bringing air into your body and then out of your body. But internal respiration, it happens within your body. It's the exchange of gases within the cells of your body, organs, cells, and tissues. So oxygen passes from the bloodstream into your cells, and then cells give off the waste product, carbon dioxide, and it's passed back into the bloodstream. Blood transports the carbon dioxide into the lungs, and then you breathe the carbon dioxide out. So if you remember from our last class, the circulatory system, the path of blood flow, it goes in through your superior vena cava, your right atrium, right ventricle, and then it goes up into a valve, and that valve goes straight into your lungs, and then the blood goes from your lungs back into the heart and through your aorta, and there's just a lot involved. So the lungs are actually a direct kind of destination for blood to go. You know, blood flows all over your body, but it especially goes into your heart and lungs. I think that's always a surprising thing because I always thought that within your heart, like it doesn't go to your lungs. Like your lungs are for breathing. Like why would there be blood in your lungs? But the blood plays a crucial role in like getting the oxygen like to your bloodstream and then getting the carbon dioxide out of your bloodstream. So yeah, just remember that the respiratory system or the lungs play a direct role in, you know, circulating blood and like the whole path of blood flow. So this is more gas exchange. So it's the delivery of oxygen from the lungs to the bloodstream. So, you know, you breathe in the oxygen and then it somehow has to get into your bloodstream, right? You know, your cells need it. And the only way for them to get it is through your bloodstream. And it also deals with the elimination of carbon dioxide from the bloodstream to the lungs. So kind of like it's called an exchange because you know you're exchanging either oxygen for carbon dioxide or carbon dioxide for oxygen. So it occurs in the lungs between the alveoli, as I said before, and a network of tiny blood cells called capillaries, which are located in the walls of the alveoli. And these walls actually share, like they're directly connected. They literally share a membrane with capillaries, so they're directly connected. And through like this little membrane, oxygen and carbon dioxide move freely between the respiratory system and the bloodstream. I think that's kind of cool. You know, it's a kind of direct network. It's like passing a baton. You know, it's either the respiratory system is passing on oxygen and the bloodstream is passing on carbon dioxide, and it's just kind of like a relay race where they hand each other the baton. So oxygen molecules attach to red blood cells, which travel back to the heart, and at the same time, the carbon dioxide molecules in the alveoli are blown out of the body with the next exhalation. So I think it's kind of cool how, you know, it directly, you know, it all connects together. You know, everything in your body connects together, which I think is cool. And that's basically how you get oxygen into your bloodstream and you get the carbon dioxide out. I think it's really cool. You know, I never really, before this year, I never really learned how that exactly worked. I just thought you kind of like breathe and then you breathe it out. Like I didn't know like the complexity and the all of that. So yeah. Oh, and here's just kind of a few diagrams to kind of see it better. I'll probably be posting more videos to better uh, see it. Like I feel like I learn better when there's like actual diagrams and all of that. So maybe you will too. So if you look at this figure, it's gas exchange in the lungs. So oxygenated blood, so blood with oxygen, is transported by branches to the pulmonary vein to the heart, and the alveoli the alveoli are basically like these little. They look like little like cotton swabs. I don't know if you want to call them that, but that's what they look like to me. And then the blue and red kind of veiny things, those are the capillaries. You can see they're very thin and small, but they're still part of the respiratory system. And oxygenated blood always flows through the red, like I said last class. And then deoxygenated blood, so blood with no oxygen, is transported by branches of the pulmonary artery to the lungs and alveoli. So oxygenated blood is kind of bringing stuff to the heart, and then deoxygenated blood is kind of bringing stuff to the lungs and the alveoli. And you can see here, if this is like the capillary, you can see that they directly share like membrane, like that white part, they're directly like connected to each other. So if this is a capillary, like this tubey thingy, I guess, blood is in and then blood kind of flows and then it goes through the membrane of the alveoli and it lets the carbon dioxide out and then the alveoli kind of pushes everything out through your exhale and that's how you expel carbon dioxide. And at the same time, when you inhale again, your alveoli is receiving oxygen, and then that goes directly through the membrane into your capillaries, and you can see the oxygen is in, and then your blood goes out into your body. And same with this diagram, you know, That's your pulmonary artery, alveoli. You can see they're directly connected. Your bloodstream is giving it CO2, and then your alveoli is giving the bloodstream O2, and it all circulates. It comes from heart and systemic circulation into your pulmonary artery, then it goes out through your pulmonary vein. If you want a refresher on like the whole blood flow thing, you can go back to last class's slides. But basically, the pulmonary artery and the pulmonary vein are parts of your heart, and that's how it kind of transports everything to your body. And then pulmonary vein it goes to your heart, and then it goes through your heart, and then from your heart it goes back into the pulmonary artery. It's like this whole complicated system that works together to help you breathe. So yeah. So I just want to reiterate, keep your lungs healthy. Your lungs are very important, obviously. Without them you won't be able to live. And the easiest way to keep that is obviously exercise every day. You want to exercise, like, when you exercise, you're breathing hard because you want more oxygen to your blood, and you need to expel the carbon dioxide faster because you're producing more of that, I guess, because you're breathing in more. And then like that's a very, I guess, simple way, but another just very easy way is just avoid tobacco. To avoid tobacco, nicotine, vaping, all of that, because tobacco causes so many illnesses that are like in um, the top 10 most common ways to die in the United States. So tobacco has been known to cause heart disease, lung disease, and cancer, which are all top 3 diseases in the United States, unfortunately. Especially lung cancer, because you're directly inhaling the tobacco and it goes in like right directly into your lungs. Chewing tobacco is just bad as smoking it. It can lead to oral, which is mouth cancer, cardiovascular disease, gum disease, and heart attack. So just avoid tobacco at all costs. Nicotine, the substance found in cigarettes and now e-cigarettes and vapes, it's a highly addictive. So once you start, it's hard to end the craving for it. So just try to avoid nicotine because it might lead to tobacco, and then your lungs they'll just deteriorate. And then with vaping, it's fairly new, so there hasn't been a lot of studies for it, but there have been stories about, people in the hospital with awful, with like really, really messed up lungs, that are even like things that doctors have never seen before. So just honestly, just avoid inhaling anything that's not air. Smoking can lead to a breakdown in lung tissue, causing a disease called emphysema, which I'll discuss in the next few slides. Smoking irritates the airways of the lungs, which can cause a chronic or persistent cough. And smoking can cause irritation in the nose and throat, as well as give you bad breath and staniology. So, there's so many cons, just try to avoid it, because it really, all the processes, we discussed, the gas exchange, like everything will kind of be altered and more messed up after you have your first cigarette. So just your body works hard to keep it healthy and treat it well. Keep it healthy. Put in stuff that will only help your body function, not hurt it. And here's like a picture of healthy lungs and unhealthy lungs. That it causes like this like tarish some substance and like impurities, and it looks very gross too. They're blackened lungs, and a lot of lung transplants, not pants, they can be done, but it's very hard to get a match, and it takes years to wait for one, because it's not like a liver where you can kind of just take a little piece from someone and then it can like regenerate back into their body. Like you need a full set of lungs, and sometimes like the lungs die before even using them, so it's very hard. Like once you mess up your lungs, they're kind of messed up forever, which is kind of, I know that kind of goes for every single body part, but especially the lungs, it's very hard to transplant. So yeah, just be good to your body. So here are some very common like diseases of the respiratory system. A lot of these are very common, and most of them can be harmless if treated, but a lot of these are also very deadly. So they kind of range in severity. So first we got asthma. You probably heard of at least one person who has asthma. It usually develops in childhood, starts in childhood, but it can start, anytime in your life. And it basically causes difficulty breathing, and it's due to an inflammation of the airway, which can be triggered by, anything from allergic reactions of like grass or like anything outside, infections and pollutions. So like anything like dust, grass, like pollen, there's just like stuff that people may be allergic to. Like it can like swell and inflame their airways. And once your airways get smaller, you can't breathe, and that's asthma. It can be treated with an inhaler, but some asthma attacks are very severe. So some people try to like avoid triggering it at all, which is very difficult. But it is treatable with an inhaler, and that's when someone just kind of I don't I'm sure you guys have like seen an inhaler. It's like when you like you put it in your mouth, it looks like a little boot, and then you like pump it, and then like there's medication in it, and then you breathe it in, and it helps your airways not become inflamed. And then we got something called chronic obtrusive pulmonary disease, which is also COPD for short. And it's this encompasses several respiratory illnesses, so it's like kind of a grouping of multiple respiratory illnesses, and they all cause breathlessness or the inability to exhale normally. And this is caused by smoking. Like asthma, it's usually caused by, something genetic or just allergies, but it's usually not caused by smoking as much, but COPD is primarily caused by smoking. And then so is chronic bronchitis, which is a form of COPD, and it's emphasized especially with a chronic cough, so a really, really bad cough. And when you cough, when you cough, that's your lungs expelling mucus and all that gross stuff, and it's just really bad. And then emphysema, which is also a form of COPD. It's also, chronic bronchitis, COPD, and emphysema are all caused by smoking, well, primarily smoking. And it's a serious respiratory illness. It's all these three are all really bad. A lot of people can't breathe properly because of it. So just don't let it develop to that, because it's completely preventable most of the time. As long as you don't smoke or something, these are usually pretty preventable. Then we have lung cancer, which are DNA mutations in the lungs. Basically any cancer is caused by DNA mutations that cause irregular cells to multiply and create uncontrolled growth of abnormal cells, which is basically called a tumor. And tumor are these uncontrolled growth of cells. And these tumors interfere with the regular functions of the lungs. So if you have like a giant mass like on or inside your lung and it keeps growing, then like obviously you won't be able to breathe properly. It interferes with like a lot of the gas exchange. Like it's just really bad. Lung cancer is also can be caused by smoking, but it also can be, like any cancer can be genetic. Or caused by other factors, but especially lung cancer is usually caused by smoking. And then we have something called cystic fibrosis or a bronchiectasis. And it's cystic fibrosis, unlike any of the other ones, it's primarily genetic. So it's passed down within families. So if your parents or someone in your family has it, then the greater chance you have of getting it. So it's a respiratory disease caused by a defective gene. So it's a genetic thing. So it's defective, and it creates thick and sticky mucus that clogs up the tubes and passageways of your bronchi and your lungs, which makes it very hard to breathe. And the mucus causes repetitive. So once you get the mucus kind of removed, that can be done through surgery. It repeats, like it never stops. Like you can't stop it. And it causes also dangerous lung infections. A lot of cystic fibrosis, like it occurs in kids, which is really sad. If you watch the movie 5 Feet Apart, that movie is about cystic fibrosis. You see the two characters, they both have cystic fibrosis, but the rule of cystic fibrosis patients is that you have to stay 5 feet apart because you like each person has their different has a kind of like a different bacteria of cystic fibrosis, and if you get too close to another person with cystic fibrosis, you can kind of give your cystic fibrosis to them, which can make it even deadlier. So it's kind of just a rule. You can't be 5 feet. You have to be 5 feet apart from any other person who has cystic fibrosis if you have it. Yeah, it's a very sad disease, but people do learn how to live with it, which is good. And there's been more ways to treat it and make people more comfortable. Then we have pneumonia, which is a very common lung disease. This is one of the ones that, isn't really caused by smoking. It can kind of happen to anyone. It's basically an infection of the air sacs in the lungs, and the infection can be bacterial, viral, fungal. You can just catch it from someone else or kind of develop it. Like it's not genetic, it's not from smoking. It's very common. Usually, it's very treatable through like antibiotics and a lot of medication, and usually it's very goes away within like a few weeks. And I did know someone who got pneumonia a few years ago. It was pretty bad for them. They were like out of school for 2 weeks, but usually like now she's back to normal. But like for some people who have like other respiratory diseases like COPD, or like their health in general is really bad, pneumonia can be super deadly, and it has been known to kill some people. Like it can be really bad, but under most circumstances, if you're a healthy person with no other diseases, it's usually fine, and it's usually easy to recover from. And then the last one I have on this list is pleural effusion, which is a collection of fluid between the lung and the chest wall in the pleural space, which is kind of like that place between the two layers of that connective tissue that surrounds your lungs and like the inner rib cage. So the fluid, you never want fluid kind of anywhere near your lungs or chest. I mean, unless it's like blood, I guess, but like you never kind of want fluid. It makes it hard to breathe. Like just imagine like water in your lungs. Like you won't be able to breathe if there's any kind of fluid in your lungs. So all of these kind of, if you like kind of notice, all of these diseases, they kind of all result in shortness of breath, difficulty breathing, and yeah, all of that. So just wanted to go over some really common ones with you guys and provide some more insight, because that's always a good thing to have. And yeah, that's the end of today's class. I hope you enjoyed it. So if you have any questions, always email me. If you have any questions during this year, if you're taking maybe anatomy and physiology in school, or another class, just email me. It'll be nice to talk with some of you guys again. Thanks for such a wonderful session of this class. I really had a lot of fun teaching you guys. You seem like a wonderful group of people. Hopefully I'll see you around. I'm not sure if we're going to be offering this course next summer, but we are running the Myri-Ed program again. So hopefully you guys will be back for some new classes perhaps. So yeah, hopefully I'll see you guys around. Thank you so much.